Hey guys, I'd like to take some time and explain a handout that I gave to you from lesson 2.1. This is an old quiz. Um, might take me some time to get through all of it, but I want to go one by one and talk about each problem. I might not write down the answers to everything, so please listen carefully. Let's begin by taking a look at this data from some third graders about their self-concept, how they feel about themselves. And we want to analyze the data. I'll give you some time to read over the problem. You can pause the video if you have to. But the first question asks us to make a rough sketch of the density curve. The definition of a density curve in statistics is it's just a curve that captures 100% of the data, so all of the data. If we look at our histogram, if you were just to smooth out those hard corners, you're going to see that for the most part, this density curve is skewed to the left. And all you have to do is sketch that pink curve that I just drew down here for number 1. My goal is that you recognize that the shape of it is skewed left. Moving on, the next question asks us to analyze a student who has a score of 62. So for the sake of being artsy-fartsy, I'm going to draw this kid, and he has a score of 62, just to give you a visual. But we're also told that there are several students that have self-concept scores higher. In fact, there are 33 students that have higher scores than him. So there are 33 kids. Whoops. Whoopsie. Now we have to read the question and figure out, they're saying something about percentile. And hopefully you recognize the fact that when you're asked to find the percentile and the z-score, we're going to take one at a time. Percentile is everybody lower than this student. Not equal to him, not higher to him, but lower than him. So if you know how many kids are in the group, which you have to go back and do a little reading, the group consisted of 78 students. So I'm going to go back down here. I know all of these kids, there's 78 total, but if 33 are higher and I am in the middle, what you're actually going to do to figure out how many are lower is you're going to take 78 and you're going to minus off 34. And the reason why you're doing 34, there are 33 kids higher, not to mention you have to add him because we're only interested in who is lower. So 78 minus 34 is going to give us 44. And to calculate a percentile, we do 44 divided by the whole group. And when I type that in my calculator, I get the 56th percentile. Now, you have to actually interpret this number. And the interpretation is hopefully easier now after we've had some discussion about percentiles. If this child is in the 56th percentile, that means 56 of his peers are scoring lower than him. I'll say that one more time. This means that 56% of his peers are scoring lower than him. That's the interpretation of percentile. Now let's switch gears and talk about z-score. If you recall, the formula for a z-score is observed minus expected divided by the standard deviation. We observed this student make a 62, but what did we expect this student to get? Expectation, always in the form of a z-score, is actually supposed to be the mean. Now I know you might argue that since this is a skewed distribution, since it's skewed, are we really supposed to report the mean? Well, technically no, but in the formal definition of a z-score, observed minus expectation, our expectation will be the mean score. So I'm going to write 56.85, and I got that by looking at my summary statistics. So 62 minus 56.85 divided by the standard deviation, which according to my summary statistics is right here, 12.35. Our z-score is 0.417. I'm not done because you have to interpret it like we did the interpretation for percentile. The interpretation for a z-score is just on average. This student is scoring almost an entire half of a standard deviation above the mean. Where did I get a half from? Well, 0.4 is close to 0.5. If you want to be very precise, you could say he is 0.4 standard deviations above the mean. That's your interpretation. Let's take a look at number 3. The word typical here means average. What do you expect? Now remember, I know it's confusing. On a z-score, we do always use mean. But if your distribution is skewed, a typical measurement for center should be your median. And the reason is because outliers are going to influence the mean more. So the median is resistant to those outliers. So please make sure you understand that a good typical self-concept score is whatever the median is, because it's skewed. And if you want to be super precise, you can list the median. The median is 59, which is right here. So going to your picture, a typical score of 59 would be about right here. And that's a better score than a mean of 56, which is actually not too much lower. So it's not terribly skewed, but it's skewed a little bit. Let's move on. We have a cumulative relative frequency graph here. And what you're going to want to do is on number 4, it asks, what are the median and interquartile range? So you have to know what median means. Median means the middle number, right? 50%. So I know that the median is at 50%. And I know that IQR has to do with 75% minus 25%. So you're going to go to your cumulative relative frequency graph, and you're going to try to figure out where these numbers are. So let's go to the 50%. I'll get you started on that. 50% is about right here. You're going to travel till you hit the graph. You're going to turn 90 degrees, and you're going to go down, and you're going to report that number. So that song length is just a little under 4 minutes. For that measurement. To calculate the IQR, you would do the same process, but you're going to draw for 75% and 25% and then subtract those song lengths. The problem asks us to draw lines to show how you arrive at those answers. So this is a tricky problem, and I'm not going to write down anything. I'm hoping that you can take my instruction and maybe some of the reading from the textbook on transformations and apply it to this problem. So what we're doing is we're transforming our data. We're going from a mean song length of 4.23 minutes and a standard deviation of 1.38. I would highlight those because that's important. Wants to add 5 seconds to each song. So when you add on 5, remember adding or subtracting definitely affects measures of center, but not measures of spread. So you will not add on the 5 to the standard deviation, but you will add on the 5 to the mean. But in addition to that, he wants to change the seconds or change the timing into seconds rather than into minutes. Now, how the heck do you go from minutes to seconds? Well, that's a multiplication problem. So he's actually doing two things on this problem. We have to know when and where it's appropriate to multiply and when and where it's appropriate to add. So if you go into your reading for chapter 2.1, hopefully you'll discover in your review that we are allowed to multiply every single term by 60 in this case, because it's 60 seconds in a minute. It will change the value of your mean. It will change the value of your standard deviation. You're allowed to multiply both of those numbers by 60. In terms of adding on the additional 5 seconds, it'll only affect the mean. It will not affect the standard deviation. So my challenge to you is to try to manipulate those two numbers, transform them, show your work. The next time we see each other, we'll discuss this problem. I hope that helps, and I hope you guys have a great afternoon.